So in this video, we're going to be talking about solving one-step inequalities. Now, solving one-step inequalities is very similar to solving one-step equations. The main difference is the way that we write our answer. So let's start by remembering that an inequality represents two things that are not equal. Therefore, if I said that the number x was greater than 6, x can be replaced with multiple solutions that would make this inequality true. So a few examples of that, I could say, well, x could equal 7. X could equal 7.5. Or maybe x equals 32.76 repeating. So the main difference between an inequality and an equation when we're solving them is how we write our answer. Okay, we can no longer just say that the value of the variable is equal to one number. We have to say that the value of the variable can be equal to a range of numbers. So let's take a look at some examples and see how that looks. So here I have 4 different inequalities, one for each of the 4 operations. And we're going to go through solving each of these and writing our answer. So the first one says 2 plus y is less than or equal to 3. So what I'm going to do is, just like I solved the equation, I'm going to isolate my variable by using inverse operations. So I'm first going to subtract 2 from both sides of the equation, or of the inequality, excuse me. And when I do that, I'm left with y on the left side of the inequality, and I'm left with a 1 on the right side of the inequality. Now, typically what we would have said is y equals 1. But in this case, the left side, 2 plus y, has to be less than or equal to 1. So there are an infinite amount of numbers that we can put in place of y that if I add 2 to it would be less than or equal to 3. So therefore, we are going to say that in order for that inequality to be true, y has to be less than or equal to 1. So if we tried that, if I substituted 1 back in for y, I would have 2 plus 1, which is equal to 3. And if I took my answer, 3, is that less than or equal to 3? Well, it's equal to, so that satisfies the inequality. So in looking at this inequality, any value that is less than or equal to 1 that is substituted in for y is going to result in having a true inequality. So in this case, my answer that I would record is y is less than or equal to 1. Here's one for subtraction. So I have w minus 1 is less than 4. So I'm going to use inverse operation. I'm going to solve this by adding 1 to both sides. And when I do that, I end up with w has to be less than 5. All right, so as long as w is less than 5, that inequality will be true. So if I pick a value, let's say I pick 3. 3 minus 1 would be 2, which is less than 4. Another number that's less than 5, 0. 0 minus 1 would be -1, and -1 is less than 4. All right, so in this case, w is less than 5. Now we have multiplication. 7 times some number has to be greater than 56. So we're going to solve this by dividing both sides of the inequality by 7. And when we do that, we're left with x is greater than 8, because 56 divided by 7 is 8. And you're noticing that the inequality symbol, when we're solving these, is always the same inequality symbol that you see in the original inequality. So in every one of these examples that we've done so far, the direction that the inequality symbol is facing is the same direction it's facing in the inequality itself. The last one, we have a division problem. We have number d divided by 3, so some number being divided by 3. has to be less than or equal to 2. So in this, we're going to multiply both sides of the equation, or the inequality, by 3 over 1. And when I multiply both sides by 3, I'm left with D is less than or equal to 6. So in this case, as long as D is less than or equal to 6, that inequality will be true. So if I put a number that's less than 6, let's put in 3. So 3 divided by 3 would be 1, and 1 is less than 2. So we are choosing a range of numbers rather than thinking of the value of the variable being only one possible solution like we had in the equations. And you might want to stop the video at this point just to review what we talked about here, because I did go from one problem to the other, and some of you might need a little bit of extra time just to take all that in. So take a minute to pause that before moving on to the last word problem. Okay, so here we are with a word problem that's going to lend itself to being an inequality. So it says a company charges 10 cents for each letter engraved. And that word engraved meaning that it's when something is carved into jewelry, such as maybe your initials or an important date. That is what they were referring to. So for every letter that you put into a piece of jewelry, the company in this case charges 10 cents per letter. So it says Bobby plans to spend no more than $5 on the engraving. Okay, so what that means is that he could spend no more than 5, or another way of thinking about it is $5 or less. So he could spend $4.50, he could spend $3, he could spend $2. He can even spend $5 because it says that he can spend no more than 5, which would include the $5. But we would not see him spending something like $5.10 because that would exceed how much he wants to spend. So it says write and solve an inequality to find the maximum number of letters he can have engraved. So when he goes into this jewelry store and is having some jewelry engraved, he needs to have an idea of what is the max number of letters he could have engraved where he would not exceed $5. So in this case, we're going to start with defining a variable, just like we would in an equation. So in this case, we're going to say that x represents the maximum number of letters. Okay, and then we're going to say that for every letter he is engraving, it's 10 cents. So if it's 10 cents per letter, that means, or in this case it says 10 cents for each letter, that indicates that we're multiplying. So we're going to say every letter that he is engraving is going to be multiplied by 10 cents, okay, which is 0.10. And this total on the left-hand side here, okay, this total on the left-hand side has to be less than or equal to $5. Okay, so if I look at my inequality, I look at the left side, it says 10 cents per letter, okay, the 10.10 times x, and I'm saying that that amount has to be less than or it could be equal to $5. Now when I solve this inequality, what I'm going to do is, this is a multiplication, so I'm going to divide both sides by 0.10. All right, and for sake of time in the video, I'm just going to give us the answer here. So in this case, 10 cents divided by 10 cents would be 1. So I'm left with 1x or just x. And the number of letters, x, has to be less than or equal to $5 divided by 10 cents, okay, which comes out to 50. All right, so what this means is that the way we interpret this is that Bobby can have 50 letters or less engraved. All right, now I'd like you to go try some on your own.